Graphing and writing equations of absolute value, day 2. So we're going to go ahead and see what happens when we look at the graph of y equals a times the absolute value of x, so with that a value on the outside. And hopefully you remember what that a value does if you think about your quadratics from last year, but if not, that's okay. So the first one we know is our parent graph, and so we talked about the other day that the vertex of our parent graph is at 0, 0. So right here, and then we usually pick 2 points to right and left and plug them in to go ahead and graph. Remember when you are graphing these to use your ruler. Also remember to make sure that you're not using your calculator, and when you're graphing, use the entire piece of graph paper to go the entire distance of the graph so you can get a full view of what it looks like. So now that we have our parent graph, we can go ahead and look at our next graph. So y equals 3 times the absolute value of x. So if we make an x and y table to help us graph, let's go ahead and start off with 0. So the absolute value of 0, 0 times 3 would be 0, so that stayed here. Then when we do 1, the absolute value of 1 is 1 times 3 is 3. And if I were to do 2, the absolute value of 2 is 2 times 3 would give me 6. Negative 1, the absolute value of that is 1 times 3 is 3. Negative 2 would also give me 6. So at 1 we have 3 and 2, 6. And on the other side, of course, it should match because we know the graph has symmetry about the vertex. And then, of course, again, use your ruler to go ahead and graph. So this is y equals the 3 times the absolute value of x. And we can see that the vertex is at 0, 0. And you can see from the parent graph, the graph got more narrow or more skinny. So then looking at the next one, y equals 1/3 times the absolute value of x. So again, you can make your x, y table. So if we start with 0, 0, the absolute value that is 0 times 1/3 is still 0. If we plug in 1, we would get 1/3. If we plug in -1, we would also get 1/3. If I plug in 2, I would get 2/3. So I'm going to do something that's divisible by 3 to make it a little bit easier. So I'm going to plug in 3. So the absolute value of 3 is 3 times a third is 1. And -3 would be also 1. The next value that's divisible by 3 that we could use is 6. So if I use 6 and -6 and plug that in, 6, the absolute value that is 6 times 1/3 would give me positive 2. And the -6 would give me positive 2 as well. So for this we have 3, 1, and 6, 2, -3, 1, and -6, 2. And again, use your ruler to go ahead and graph. And for this graph, you can see from our parent graph that it got more wide. So in conclusion, if the absolute value of a is greater than 1, then the graph is what we call stretched vertically. So you can see that the y values are stretched upwards from the parent graph, and this graph in green, the y values are going to be what we call compressed. So the graph is compressed vertically when the absolute value of a is less than 1. So we call that again a vertical compression, and the other one was a vertical stretch. So make sure that you use those vocabulary terms when you are talking about these functions. And the vertex for this one again was also at 0, 0. Now, again, we're not using our graphing calculators, but you could always, use your graphing calculator to check your work when you are finished. So if you go to your y equals, you can go to math And if you right arrow to number, you can see that first one says ABS, which stands for absolute value. So if I hit that, we can get our absolute value bars on our graph. So if I were to go ahead and just graph the parent graph, y equals the absolute value of x, you can see that's our graph. And we could compare it to the ones we just did. So we could plug in 3 times the absolute value of x. So if we look at that graph, you can see that was the next graph that we did, and you could do the same thing with 1/3. So you can use that to check your work. All right, so for the next part, it says for each problem below, identify the types of transformations made to the parent graph, and then we're going to go ahead and graph it. So looking at this first one, 2 times the absolute value of x, that's going to be a vertical stretch by a value of 2. So that means we're changing our y values by 2. So if you want to do it this way, you can kind of think of that. If we're changing our y values by 2, that means we're changing our slope. So that means that that number in front changes the slope of the lines. Because if you look at these graphs up here, notice there was a 3 in front of that graph that's red, and look at the slope. It's up 3 over 1, up 3 over 1. The graph in green, 1/3's in front, notice it goes up 1 over 3, up 1 over 3. So over here, that means our slope we're going to be using is plus or minus 2. And so our vertex is the next thing you'd want to find. So the vertex, remember h comma k, so y equals, in this case it's the absolute value of a times x minus h plus k. So the vertex here is at 0 comma 0. And if we use our slope to graph instead of plotting points, which you could still do by plugging them in, we go up 2 over 1, up 2 over 1, and then same thing on the other side of the vertex. And that gives me my graph. And there we have the graph. And again, always use your rulers when you are graphing a straight line. For the next one, our value in front, our a value is equal to 1/4. So that means we're using a slope of plus or minus 1/4 from our vertex. So the vertex again has not changed from 0, 0. So we have 0, 0. So now we're going up 1 over 1, 2, 3, 4. And then up 1 over 1, 2, 3, 4 going the other direction. And then again, use your ruler to connect those values. And that would be our graph. And then the last thing we want to do is talk about what happened to our graph. So since our a value is equal to 1/4, that is a vertical compression by 1/4. So that means we took our y values from the parent graph, was y equals the absolute value of x, and we compressed them down by 1/4. So looking at the next one, and something that we didn't talk about up here, the reason that these say the absolute value of a is greater than 1 and the absolute value of a is less than 1 is because remember that negative in front we talked about yesterday is actually a reflection across the x-axis. So we actually have 2 different transformations that we are doing to our parent graph. So the first one is a reflection across the x-axis, and then we have a vertical stretch by 4. So for this one, the slope of this equation we're still using is an m value is equal to plus or minus 4. The vertex is still at 0 comma 0. But because of the fact the negatives here, that means, again, remember it reflects across the x-axis. And that 4 is going to be a vertical stretch by 4. So we're going to go down 1, 2, 3, 4 over 1. Same thing on the other side. Again, that's because the negative in front reflects our graph. And that's it. So again, let's go ahead and take a look at graphing our transformations. So again, we have that a value in front, we have the h, and we have the k, and recall the parent graph is y. Oops. So the parent graph is y equals the absolute value of x. So that A, if it is less than 0, that's a reflection across the x-axis. When the absolute value of A is bigger than 1, it's a vertical stretch by the absolute value of A. And when its absolute value of A is less than 1, it's a vertical compression by the absolute value of A. That H value, remember, if it's x minus h inside, that moves the graph to the right h units. And when it's x plus h on the inside, that moves it to the left h units. Because remember, to get that minus that's here to be a plus, you have to plug in a negative h value. So that's when your h would be negative. That's why you're moving it to the left h units. And then for this next one, when it's plus k, we go up k units. And if it is minus k, we go down k units. So that is our transformed equation. Describe the transformations made to each function below without graphing. So for this, you want to identify your A, your H, and your K. So here, notice that your A value, if we go back to our chart, our A value is, in this case, not less than 0, so we're not reflecting it. The absolute value of A is bigger than 1, so that means it's a vertical stretch by the absolute value of A. So that means that this is a vertical stretch by 2. And then the H is 3, so that moves it right 3. And the K is 4, so that moves it up 4. And the vertex is at 3, comma 4. So I want you guys pause the video and see if you can do the next two on your own. And when you're done, you can unpause it to check your work. So here, our A value is actually equal to -1. Your H in this case would be equal to -7, and your K is equal to -5. So again, if you want to use that chart, so if our A value is -1, that's less than 0, it's a reflection across the x-axis. The absolute value of A is, again, in this case, -1, so the absolute value of -1 is 1. 1 is not greater than 1, nor is it less than 1, so we're not vertically stretching or compressing, because remember, when you multiply something by 1, it doesn't actually change your equation. The negative, however, does make it open down instead of up. So this is a reflection across the x-axis, and then that -7 moves it to the left 7, and then we go down 5. So those are all the different transformations that are being made, and the vertex is at -7, comma 5. So looking at this last one here, this is our A, then H is not there, and this is our K. So A is equal to -1/2. H in this case is 0 if it's not there, because remember, we're adding or subtracting something that doesn't make a difference, which is 0, unlike multiplication. So multiplying by 1, it doesn't make the difference on the equation. So then our K value equals 1. So that A, the negative, means we have a reflection across the x-axis. We are also that 1/2, the absolute value of A is 1/2, and that's less than 1, so that is a vertical compression by 1/2. And then that K value moves our graph up 1. And our vertex is at 0, 1. So let's go ahead and look at steps for graphing the absolute value. So step 1, find the vertex and plot it. Then we're going to use that A value to determine if the graph opens up or down. Use the A value to determine the slope of each line from the vertex, and then we're going to graph checking using our graphing calculator. So could you make a t-table and to graph this and plug and point shirt? Just takes a little bit longer, but whatever works for you is fine. So in this case, our vertex is, remember, h comma k. So this is our h, our k is not written, so really it's plus 0. So the vertex is at 3 comma 0. The graph here, we know because our a value is negative, opens down. And the slope that we're going to be using is plus or minus that 1/5, which is in front. So my vertex is at 3, 0. And we know we're opening down. So for my slope, I'm going down 1, right 5. And then down 1, left 5. And I could keep going on this side, down 1, left 5. And then again, you want to use your ruler for graphing. And that gives me my equation. So what were the transformations that we made? We had a reflection across the x-axis, a vertical compression by 1/5, and then we also moved our graph to the right 3. So why don't you guys see if you can do number 2 on your own, then when you're done you can unpause the video and check your work. So for this one over here, this is our A, our H, and our K. So we know that the vertex in this case is -1, -2. It's going to open up because our A value is equal to +5, and the slope that we're using is plus or minus that 5 because it's your A value. So the vertex is -1, -2. Since our graph's going up, we're going to go up and then over for our slope. So up 1, 2, 3, 4, 5 over 1. Up 1, 2, 3, 4, 5 over 1. And then of course we know it has to match on the other side of the vertex. And again, you want to use your ruler to go ahead and connect the points on our graph. And so now we have our graphs. And again, you can use your graphing calculator to check your work if you need to, but we're going to go ahead and skip that for now. For the next part, we are writing the equations of absolute value graphs. So given the graph, write the equation. So step 1, find the vertex. Step 2, does the graph open up or down, which is your A value. Step 3, find the slope of the line, which gives you your A value. And then we're going to write the equation in the form of this. So to write the equation for each absolute value graph below, we want to again first identify the vertex. So here you can see, because it gave it to you, that the vertex is 0, 2. The graph opens up, which means we have a positive A value, and our slope is up 1 over 2, up 1 over 2. So we check the other side. So that means our slope is equal to plus or minus up 1 over 2. So again, because the graph is opening up, we know our A value is going to be positive, so our A is equal to 1/2. Our H in this case is equal to 0, and K is equal to 2. So for the equation, y equals 1/2 times the absolute value of x minus 0, which we don't need to write, and then plus 2. So let's go ahead and look at this equation over here. So the vertex again was given at 0, 3. The graph is opening down, which means we have a negative A value. The slope, if you look, goes down 2 over 1, down 2 over 1. So let's check the other side. Same thing, down 2 over 1. So the slope, we have plus or minus 2. So the equation is y is equal to our A value. It has to be negative because it opens down. So -2 times the absolute value of x minus h, which is -0, which we don't need to write, and then plus 3. So why don't you guys go ahead and see if you can do these next two equations on your own, and then when you're done, I pause the video, and when you're done, you can unpause the video. So looking at this next one, we see that the vertex is at 2, 0. It opens down, and the slope looks like it's going down 1, 2, 3 over 1. So plus or minus 3. And then the equation for this would be y equals negative 3, because that's the slope, times the absolute value of x minus 2, because that's our h value, and then we don't have a k value in this case. Over here for this one, we have the vertex at negative 1, negative 2. This opens up, so we have a positive a value. The slope is going up 1, 2, 3 over 1, up 1, 2, 3 over 1, so plus or minus 3. So y equals 3 times the absolute value of x plus 1 minus 2. Again, because remember it's y equals a times the absolute value of x minus h plus k. So to get that minus h, we have minus negative 1, which is why it's x plus 1. And that's it.